Hi, I'm Emergent. This is a short video giving an overview of emergent robotic skills via unsupervised off-policy learning. There has been a spur of work in unsupervised learning for robotic control. Recent work has shown that non-trivial skills can emerge from interaction with the environment without any rewards or supervision. However, the results have mostly been demonstrated in simulation with very limited real-world results. This is primarily due to the sample inefficiency of the current methods. We build upon the recent work of dynamics-aware unsupervised discovery of skills, or DATS, which allows for discovery of diverse and predictable skills without any rewards. In this work specifically, we demonstrate real-world execution of unsupervised learning by developing an asynchronous off-policy variant of DATS. To give a brief overview of our proposed learning algorithm, first, we have a centralized replay buffer which stores all the transition data required by the actors in a first-in, first-out method. We have N actors which will be collecting transition data using the latest copy of the policy. Now, since we are in an unsupervised learning context, we need an intrinsic reward signal for our agent to optimize. We train another neural network on randomly sampled batches of transition data from the buffer. This neural network will be used to compute the intrinsic reward function for DATS. Next, we want to train our policy. We again randomly sample batches from the replay buffer. We compute the intrinsic reward for each of the batches using the latest copy of a reward function. With these reward-labeled transitions, we can update our policy using any off-policy learning algorithm. From time to time, this updated policy will be synced with our actors in the environment, and we keep iterating the cycle. To test our unsupervised learning algorithm in the real world, we set up a closed play area tracked using the phase space motion capture. We have two tethered quadrupeds, which will be the actors used for data collection. The object demonstrated in this picture is only used at test time. Now we show a video demonstrating the evolution of the skills learned by quadrupeds using our unsupervised off-policy learning algorithm. We start off with randomly initialized policy for our actors. These actors will take random actions, which means the initial exploration will primarily constitute trajectories of agents falling down. After about 3 hours of data collection, we can see the robots have learned how to stay upright. This means that robots will be exploring more meaningfully while minimizing their rate of falling. About 6.5 hours into training, we start to see locomotive behaviors emerge. While these behaviors are still somewhat nascent and the skills learned by these robots are not disentangled or interpretable, we can clearly see the robots are moving towards acquisition of locomotive skills. For the majority of the remaining training time, these quadrupeds are improving their skills iteratively while discovering a greater diversity of skills. After about 14 hours, we can see the skills are covering more space and are moving in different directions as well. As the agent moves in different directions predictably, our intrinsic reward also starts climbing up. The result is what we desired, a set of diverse and predictable skills acquired autonomously without hard-coded rewards or demonstrations. With a little more training, the emergent skills now provide definitive and efficient locomotive skills. And again, just to emphasize, these skills have been learned purely using self-supervised exploration and intrinsic rewards. Next, we'll show an example of how the learned skills can be repurposed for downstream tasks. In this particular case, we can compose the learned robotic skills using model predictive control, which requires no further training. If you find our work interesting, please check out Emergent Real-World Robotic Skills via unsupervised off-policy reinforcement learning. Thank you for listening.